Transformation of exponential functions. The general formula of exponential function is a times b in exponent x minus h plus k. A represents the factor of vertical stretching or compression. B is the base. X is an exponent, but if we have here, for example, a coefficient, the coefficient in the front of the x represents the horizontal stretch or compression. And when we have minus h here, x minus h represents the horizontal shift or translation of the exponential function, and k represents the vertical translation of exponential function. So now we have a h of x is equal to 3 in exponent x, and g of x is a 3 minus x. So this represents a reflection over y-axis. When over y-axis. So just let me write here over y-axis. Over y-axis. For instance, if f of minus x, if we are changing the minus sign here, f of minus x is a reflection over f of x over y-axis. So it means that just this is the f of x. If we, for example, change here just to the minus sign, is going to be the reflection over y-axis. So now let's go and let's see a reflection over x-axis. So reflection over x-axis happens when, for example, minus f of x is a reflection of f of x. So if f of x, we are just changing a sign in the front, then is going to be a reflection over x-axis. For instance, f of x is 3 in a x. If we write a sign minus in the front, like we did it before, like we did here, so we already see the function g of x is a reflection over x-axis of the function f of x. Now let's see the horizontal shift, left and the right shift, or a horizontal translation. Horizontal translation means that when here the h exists is a greater or is a different from 0. So is any real number but different from 0. For instance, of the parent function here, f of x is equal to the phi in exponent x. But if we have a f of x minus 2, and it means that we have a right shift for 2 units. If, for example, we have a f of x plus 2, we have a left shift for 2 units. It is very similar with a quadratic function and other function when we are talking about the horizontal translation. So now let's see to the next. Vertical shift or vertical translation, vertical up and down shift. It happens when exists k is different from 0. So for instance, the parent function here is f of x is equal to an exponent x. If we have a g of x 2x plus 2, the parent function is going to shift for 2 units up. So is the shift of the parent function for 2 units up. For example, if we have a h of x is 2x minus 2, so we have a vertical shift of parent function for 2 units down. So now let's go to the next functions. Uh, what means? It means that, for example, that the base is bigger, is going to happen here like a vertical stretch, or the graph of the function is going to be steeper. For instance, if we have a function f of x in 2 in exponent x, but if we look at, for example, g of x 5 in a 5 exponent x with a greater base, this function is going to be much more steeper. But here, for example, h of x is a greater base, is a more steeper. This is 100, the base is 100, so it means it's a more steeper. The greater is the base, the more steeper is the graph of the function, or is more stretched if we want to express a bit different expression. So now let's see vertical stretch of exponential function. Vertical stretch happen, for example, in a general form here. The absolute value of a is greater than 1. For example, we have a parent function 3x. And in the front here, we have the factor a is 2, so it's greater than 1. So it means we have a vertical stretch of the parent function. For example, if we are looking here, y is equal to 5, 3x, so this is the greater stretch. But what's happening here, for example, if we are analyzing, the intersection point in the y-axis is 0, 1. And if we have a 2, is going to multiply this point here, and 2 times 1 is 2, so the point is going to be 0 and 2 in this function. But for if we are looking, for example, the y is equal to 5 times 3x, and with the 5, if we are multiplying the intersection point then is going to be 5 times 1 is a 5, so the intersection point is going to be 0 and 5. This is one way how we can look at how is the change in the y-intercept of the function when we have a vertical stretch. Vertical compression. Vertical compression happens when a is the absolute value of a is smaller than 1, is less than 1. So for example, we have parent function like we had before, 3 in exponent x, and if it happens here 1 over 2 is less than 1, so this function is the parent function is going to be compressed to reach to this point here. So and now this point here, as I mentioned before, 0.1, if you multiply by 1.5, you can get 0.5. So now the y point is 0 and 0.5. So what's happening with the h function if it's 1 over 10? So it's going to be more compressed. The parent function is going to be compressed to reach to this point, and the intersection point in the y-axis is going to multiply by the y-axis 1 by 10. If we are multiplying here by 110 of both points, for example, you get a 0 and 0.01. 0.1 is going to be the y-axis. And same thing is happening if, for example, it's more smaller, this number, 1 over 100, the factor of vertical stretch or compression, but in this case compression. And if you multiply 1 over 100 by 0 is 0, is 0 here, and 1 divided by 100, which is 0.01, times 1 is 0.01. So this is going to be the parent function to reach to this point. It's going to compress more. It's going to be more compressed to reach to this point.